Hello, today we want to talk about one of the main elements in every circuits, and that element is resistor. So resistor or resistance come from the concept that if electrons want to flow or go through one wire or one conductor, we have some resistivity, some resistance. Assume that you want to drive by car in a road. You drive without any resistance with higher speed is fine, but sometimes there is a traffic, there's a lot of cars, or the road is narrow, then we have some resistances. In conductors, we have the same concept. And that one is the resistance of any material. So any materials have a resistance during flowing of the current through that one. Also, we have one element as a resistor, and these elements make some resistances inside of any elements that we want. So this is the component, and normally in the component we have some colors, some bands, and these colors will make the number for that or value for that resistance. But anyway, if we want to calculate the resistance of any wires and materials, we have these equations. R is equal to rho L divided by A. So rho is the resistivity of that material. It depends on the material. L is the length of that material, and A is the area. So assume that we have a wire like this. If we have a resistance of R, if we increase the length, for sure, the new resistance will be higher. And assume that we have a wire like this area. So we have some resistance, more or less same to the example of the road. If we have a wire with higher area, the resistance will be lower. So this is the equation that we have. As an example, assume that we have a wire and we have a resistance and we want to calculate the resistance. So the equation is R is equal to rho L divided by A. So rho here is 0.028 micro ohm per meter. So ohm is the unit for resistance. So if you write 0.028 macro 10 minus 6 multiplied to L is 235 meter divided by A, area is 2.5. So unit should be in meter multiplied to 10 minus 4. So if you calculate this one, so we will have the value of this ohm. And normally resistors have also some impact or some change by changing of the temperature. So if we have the resistance of RF, so in this in previous example the RF was 2.6. So if we have a resistance, normally the resistance that we have, the value that you can find is for the temperature of 20 degree. So if we change the temperature, for example, if you have higher temperature, then the resistance will change, go higher. So Tref normally is 20 degree Celsius. So T is a new value. So if we have, for example, 25 degree, then this one will be 5. And alpha is the temperature coefficient that it depends on the material. So all of these will make a new resistance. We'll have in the next slide one example about this. Anyhow, if we have a resistance, this is the symbol for resistance. Here we will have the voltage, here we will have the current, and here we have the number or value for that resistance. So if we have two of them, we can find the third one based on the Ohm law, and here is the Ohm law. So if we multiply R or resistance to I, the current, then we can find the voltage. And the power that consumed through this one is Ri2 or V2 divided by R. As an example, if we have one resistor with a resistance of 15 ohm, if we increase the temperature by 5 degrees, how much will be the new resistance? And the temperature coefficient is 0.004. So we had this equation. So our ref is 15 here, 1 plus 0.04 multiplied to 5 will be 15.3. So for this resistor, if we increase the temperature by 5 degrees, then we will have 0.3 ohm more resistance on that one. Another example, here we have one battery that is connected to the resistor. The battery is 12 volt and the resistor is 6 ohm. Based on Ohm law, if you want to calculate the current V is equal to Ri. So I is equal to V divided by R. So V is 12 and R is 6, so it will be 2 ampere. So this current will be 2 ampere. If we want to calculate the power, we have this equation Ri2, so R is 6, I2 is 4, so totally will be 24 watts. In another example, we had one student measured the current of this circuit. We have a battery is connected to light bulb, and the current is 0.1 ampere, and the battery is 12 volt. So how much is the resistance for this light bulb? So voltage, we want to find the voltage. We have the voltage is 12 volt. The current is 0.1. So R is V divided by I. So 2 divided by 0.1 will be equal to 120. In resistors, we have some rules regarding to the making the connections of them and calculate the new values. So we can connect the resistors in parallel or series, and we can make a new resistors. So, and in the circuits, normally we have different type of connections. For example, this is a series connection. If we connect one resistor to another resistor in series, we have this kind of connection. And how we can recognize that the connection is series or parallel? In the series connection, we have the same current that go through all resistors. So here you can see this current go through this and back. So we have the same current, so they are connected in series. So if you want to calculate and find the total resistor from beginning to the end, just make a summation. So R1 plus R2 plus R3 is Rs. In parallel, we have the parallel connection is something like this. So in parallel connection, we have different current go through each resistor, but we have same voltage polarity through them. And if you want to calculate and find the equivalent resistor for this circuit, you can find from this equation. 1 divided by R total is equal to the summation of 1 divided by each of them. For example, here, if we have a 12 volt battery that's connected to 3 series resistors, 100 ohm, 400 ohms, and 300 ohms. If we want to calculate and define the current, we can first find the total resistors. So the total resistors, we have 3 of them in series, 400 plus 300 plus 100. So we have 800 ohm in series. So if we divide 12 by 800 ohm, we can find 15 milliampere as a current that go through this one. Now we have example. If we want to calculate how much is the equivalent resistance of this one or find the current, we can see the 12 volt, 12 ohm resistor is in parallel with these two. So these two are in series. We can replace these two with one 12 ohm. So now we have two 12 ohms resistors in parallel. So 1 divided by R is equal to 112 plus 112. It will be 6 ohm as R. So here we will have the 6 ohm that is in series with another 6 ohm. It will be 12 ohm. So the circuit will be something like this: 12 ohm, 12 volts, and current is 1 I will be V divided by R will be 12 divided by 12 will be 1 amp. And here we have another example. We have two resistors in series, and then these two will be parallel with this one, and then will be series by this one, and again will be parallel by this one to the end. So if you calculate by the end, the final value will be 10 ohm. So this is something as your homework.